example, we were given that one side was 16 inches, the other side was 15 inches, the other side was 19 inches. So to find the perimeter, and that's the distance of the outside of a figure, you would just add up the length of all the sides. So we would do 16 plus 15 plus 19. What do we get when we do 16 plus 15 plus 19? What is it? 50. So it would be 50 what? Inches, just 50 inches. So, yes, it doesn't look like it's 50 inches. It's all, things aren't always drawn to scale in geometry, so no, that's not probably technically 50 inches. But hypothetically speaking, if we had a triangle with those dimensions, the perimeter of that triangle would be 50 inches. Okay. Questions over there? If we take a look at B, I have this side is 5 and that side is 7. We need to be able to find the other side. What do we know about the length of that other side? Yeah, it's equal to 5. Now, how could you tell? And they have the same tick marks. What kind of triangle is this? Isosceles. Two sides are the same, so it's an isosceles triangle. So this side right here is 5 yards. This side over here is also going to be 5 yards. And then again, we're finding the perimeter. So just like we did with the last example, you just add up all the sides. So we do 5 plus 5 plus 7. And what is 5 plus 5 plus 7? So 17 yards. Again, this is not actually 17 yards. It's kind of more of a hypothetical. If we had a triangle with those exact dimensions, it would be 17 yards for the perimeter. Questions over there? So if we take a look at the next example, we want to find the perimeter of the triangle below. Okay? Well, they gave you that this side is BU was 11. They gave me that this side over here, WU, was 17. What's the problem? We don't know VW. But what type of triangle is this? It's a right triangle, right? How can we find that side if we know this is a right triangle? Yeah.
11 and 7 minus 9.
Be careful. We can't, angles and sides don't really match up. So because this is a right angle, we don't really do anything with angles and sides. So think about, what have we talked about? What did we review at the very beginning? What is it, Isaac? Yeah, we have a right triangle, so we can use that Pythagorean theorem, a squared plus b squared equals c squared, to help us find that missing side. And then we can find the perimeter. So label your C. Again, go to your 90, go across, that has to be your C. Then it doesn't matter, I'll make that A and make that B. So we do a squared, which that's the side we're trying to find, we don't know, plus b squared equals c squared. 11. Clean it up. What is 7 squared? 49. What's 11 squared? 121. And what do we have to do with 49 to get a by itself? Subtract it. 121 minus 49. What is 121 minus 49? 72. What do we have to do to both sides? Square root. Here's the thing, and this is going to help us with what we are doing here in a second. We want the most accurate answer as possible. Okay, so to get that, do not round yet. You are just going to leave A as radical 72. And we're going to do this more in this lesson. So leave it as radical 72. We will round at the very end. Because if you round now, you're shortening that length of that side. So then when you add up all your sides, it's technically not the most accurate perimeter because you're rounding too early. Okay? So we're just going to keep it as radical 72. It's a little weird, I know. But just keep it as radical 72. We'll round at the very end. So now that we know the length of all our sides, again, we want to find the perimeter, so add them up. So we're going to do 11 plus 7 plus radical 72. So how that's going to look, I'll pull up Desmos or the graphing calculator. So you're just literally going to type that into Desmos, like so. So you do 11 plus 7 plus radical 72. I always like to put my radical last. So now, when we round, our answer said round to the nearest 10th. That's how many decimal places? 1. So we go to the 4, go to the next one. What would that 8 do to the 4? Bump it to 5. So rounded to the nearest 10th, our perimeter is about 26.5 feet, roughly. Okay. In your graphing calculator, how you would type that in, you do 11 plus 7 plus, you hit second x squared to get your radical, if you didn't know that yet, and then 72. If you did the radical 72 first, make sure arrow out. That's why I always put my radical last. Not the word about arrowing out. Arrow out, and then do plus 11 plus 7. If you don't arrow out, you're taking the square root of all those numbers, and that's not right. So you get the wrong answer. Okay, so you have to make sure, remember to arrow out. Same thing with Desmos. If you put your radical first, make sure you arrow out from underneath that radical. Okay, or else you're going to add up everything underneath the radical and get the wrong answer. Questions over that? Okay. So all the examples we've talked about so far were in the non-coordinate plane. Okay. The rest of these that we're going to talk about is how to find the perimeter in the coordinate plane. And again, to find perimeter, we have to add up all the sides. What's the problem here with this example? We don't know the length of any of the sides, right? They didn't tell us what they were. In all our other examples, they told us what they were. Okay? But when we're dealing with the coordinate plane, how can we find the lengths of all those sides? What could we do? What do we have in our toolkit to help us find those sides? The Pythagorean theorem, just like what you should have done on your quiz, just like what we did on Friday last week. Whenever we're trying to find length in the coordinate plane, we use the Pythagorean theorem. So if we want to find the length of this yellow side right here, you just make a right triangle with that side. Okay. The side you're trying to find is your C. And then it doesn't matter, make one of the legs A and one of the legs B, and then we can use the Pythagorean theorem to find it. Okay? We'll call this one side 1. So we're just going to use A squared plus B squared equals C squared. So we're just finding the distance of those sides, the length of those sides, by using the Pythagorean theorem. What you should have just done on your quiz, what we did last week, what you should have done yesterday. Okay? So count. What's the length of our A? 7? 7 squared plus, what's the length of our B? This was 7, this was how far? 1, 2, 3. So it would be 3 squared. What is 7 squared plus 3 squared? What is it? 58. And then what do we still have left to do? What do we still have left to do? Square root it, right? Get rid of that square. Here's the thing, just like we did on that last example. Do not round to the very end because you're throwing your answer off too early. So leave it as a radical. I know it seems very odd, but leave it as radical 58. We will round at the end. If you round too early, then you keep shortening or lengthening, or shortening, I guess, because we're rounding, a side, or lengthening it. So you're not getting the most accurate answer as possible. Okay? And on the OST, they don't see that you knew what you were doing, you just rounded too early. They just see that you typed in the wrong answer. Okay? So that's why we have to wait to the very end to round it. It's really important. So right now, that side length is just radical. We're going to do the same thing for this other side. We want to find the length of this side. So I make my right triangle with that side. Again, the side we're trying to find is our C. And I'll make this side A and that side B. And we're just going to, again, use that Pythagorean theorem. What is the length of my A? We count. What's the length of that A? 7. What's the length of my B? 1. So this was 7 and that was 1. So we have 7 squared plus 1 squared equals C squared. What is 7 squared plus 1 squared? 50. Again, what do we still have left to do? Square root. Don't forget to square root. And again, leave it as radical 50, unless it's a perfect square. Okay? If you have a perfect square in the radical, and when you take the square root of it, you get a whole number, then you can take the square root, that's fine. But when you take a square root and you get a decimal, leave it as that square root. Leave it as radical 50. To find our third side, do we need to use the Pythagorean theorem to find our third side? Why? Yeah, it's nice and flat. There's no slant to it. So how do we find the length of that third side? What do we just have to do? Just count. Yeah. You just start at one point, count 1, 2, 3, 4. The length of that side is 4. So when you have perfectly flat horizontal lines or perfectly straight vertical lines, there's no slant to them, all you have to do is count. Sometimes we see that try to use a Pythagorean theorem, but we can't. Okay? They're straight. There's no slant to it. So again, to find the perimeter, what do we have to do with all 3 of our sides? Add them together. And you'll be surprised how many students do a beautiful job of all this work. And they find all the sides perfectly. But they forget to find the perimeter. They find the sides and then they stop. It asks for the perimeter, so you have to remember after doing all that work, add your sides up. So in your graphing calculator, second x squared 58. Make sure you arrow out plus second x squared 50. Again, make sure you arrow out plus 4. I wrote 8 at the bottom. I don't know why I did that. Okay? And then the directions say to round to the nearest tenth. Again, how many decimal places is that? 1. So I go to the 1, go next door. What does that 8 do to the 6? It bumps it up to a 7. So the perimeter is 18.7. There's no just units since there's no terms of measurement. If you forget to put units, I'm not very picky about labeling. I don't think they make you label on OST. So I'm not too big if you forget to label. But try your best to label. Right. Questions over that? Okay, make sure you arrow out of those radicals when you take the square root. And your calculator. So look at example 3. Find the perimeter of the triangle graph below. Round your answer to the nearest tenth. Okay. Well, first says find a. Oops, that's supposed to be a C. AC. AD. AC. Okay. Find AC. Well, AC is nice and slanted. A to C. Okay, so make our right triangle. Side you're trying to find your C. Make that A, make that B. So we plug our values into the Pythagorean theorem. Did I really need to draw that second triangle? No. Why? What type of triangle is this? It's already a right triangle. You could have done that. Okay? You could have drawn a second triangle. That's fine. You would have just gotten the same dimensions as the other sides. Because this is already a right triangle. It's already kind of drawn for you to find AC. You can just use the triangle itself, right? So the side you're trying to find your C, I'll make that my A, and make that my B. So what's the length of my A? 4. What's the length of my B? 6. So what's 4 squared plus 6 squared? 50. Again, what do we have left to do? Square root. And again, don't take the square root to the very end. Just leave it as the radical. That's up your answer. Okay? And it's really nice because AB, we already found AB. AB is nice and straight. What's the length of AB? 4. We already counted it. We counted it here. It's 4. What's the length of BC? It's nice and flat. We already counted it. It's 6. That was a nice one. And again, to find perimeter, add up your sides. 4 plus 6 plus radical 50. And you're using your graphing calculator. 4 Desmos, 4 plus 6 plus second radical 50. You don't have to arrow out here because your radical is at the very end. What did the directions say to round to? Nearest 10th. So we rounded this to the nearest 10th, it would bump it up to a what? 1. So it's 17.1. So the perimeter is 17.1 again in units. Not a big deal if you forget that. Questions after that? We got one more. So we want to plot our points. Again, the biggest thing here is if we accidentally plot a point wrong. If we accidentally plot a point wrong, it will throw everything off. Plot them into Desmos. Plot them into Desmos. And if you don't like writing on your computer screen, that's fine. But at least mimic what the points are on Desmos on your grid paper. Double check them. Okay? If not, what we talked about, you can just plot these points into Desmos and do all your work on your computer screen with the extra mark. Okay, like we talked about the other day. Both ways are fine. Okay, but plot your points. We're going to go to 2, -1, 8, 1, and 7, 3. And I'm going to label C, A, and single text. Okay?
Plot it 2, -1.
Is it 2, -1? What did I plot? 2, 2. Oh, thank you. See? Welcome back. I just plotted my point wrong. And I'm a human being, so that happens. That's why I highly suggest plot it into Desmos. We are all human, and we simply misjudge where 2, -1 is. It happens. We are not perfect. That's why we need to plot it into Desmos. Check it. Okay.
The other one is 8, 1.
It's 8, 1. I put 8, -1. See? Look at that. Catching it all over the place. Let's replot it. That's why we use Desmos. 2, -1, 8, 1, and 7, 3. See? Now are those right? That's why we use Desmos for human beings. You might be a little tired one day, and oh yeah, 8, 1. Plotted 8, -1. I see it all the time. I do it all the time. We're humans. Plot it in Desmos. Double check how you plot your points. Okay. So to find distance, all of our sides are slanted, so let's find CA first. Again, doesn't matter which side you find. Here's CA. Make my right triangle. Side I'm trying to find is my C. Make that A, make that B. When we plug it into the Pythagorean theorem, what's the length of my A? 2. What's the length of my B? 1, 2, 3, 4, 5. One more. Makes what? 6. And think you're going from 8 to 2. So going from 8 to 2, you move 6 units. What is 2 squared plus 6 squared? 2 squared plus 6 squared? 40. What do we have left to do? Square root. Do not forget to do that. Again, do not round here. Just leave it as radical 40. And now let's find AT. This is a little guy. If you take a look to find AT, I do it up and then over. How far? My C, I'll make that A. that be? What's the length of my A? 1. What's the length of my B? 2. It's a little side. So I do 1 squared plus 2 squared will give me my C squared. What's 1 squared plus 2 squared? 5. Again, don't forget square root. So the length of that side is just radical 5. Very small. And my final side, CT. Again, make my right triangle with CT. That's my A, that's my B. What's the length of my A? 1, 2, 3, 4. That's 4 squared. Plus what's the length of my B? 5, so plus 5 squared. C squared. What's 4 squared plus 5 squared? 41. Again, what do we have left to do? Square root. Don't forget to square root. And leave it as a radical. Just leave it as radical 41. Are we done? What do we still have left to do? Add up all the sides. You will be surprised how many students will do all this beautiful work. Get all the sides right. And then forget the most important part. Adding them up. So we add them up again in your calculator. I'll do Desmos this time. Okay? Radical 40. Make sure arrow out. Plus radical, what is it? 5. And arrow out. Okay? Plus radical 41. And our answer is, what did the directions say to round to? There's 10. 100. 10. We're just using 100. Here's 100. So when we round it to the nearest 100, that's how many decimal places? 2, right? So go 1, 2, go next door. What does that 3 do to the 6? 6. So that would be 14.96.